Hello everybody, my name's Anthony Kyriakidis. I'm the Scottish Renewables Manager at the Energy Saving Trust. Welcome to today's webinar, which is going to cover solar photovoltaic systems, commonly known as solar PV systems. This webinar is part of a series of webinars we're delivering, and the work's funded by the Scottish Government as part of their support for home renewables, which is there to help lower Scottish householders' energy bills and CO2 emissions and increase the market for renewables, and particularly domestic renewable systems in Scotland. Some general points about the webinar. You can hear us, but we can't hear you. That's perfectly normal for a webinar, so don't be alarmed. It'll probably last approximately 45 minutes, and there'll be an opportunity for questions. You can ask questions at any time through your control panel, which you should be able to see on your screen. But we'll typically answer questions at the very end, and in some cases we may not have time to answer all of them. If so, what we'll do after the webinar is that we're recording it, and then we'll send you a link so you can watch it back. And in that, when we send you that email with a link, we'll also include answers to any questions we didn't have time for. We've got two speakers today. The first speaker is Ewan Snedden. He's representing the Solar Trade Association and the Forster Group. He's a senior engineer there, so knows solar PV systems inside out. And we've also asked Mark Bragg, who's a Scottish homeowner and a member of the Green Homes Network. He is a proud owner of a PV system and lives with one every day. And he's a homeowner just sharing his experiences of putting a system in and living with it. We're also, at the very end, going to quickly cover further support for installing solar PV that may not have been covered by you and Mark, and then we'll have some questions and answers at the very end. So, without further ado, I'll pass you over to Ewan Snedden. Thank you.
Hello, and good afternoon, and thanks everyone for joining us for this webinar. As was introduced, my name is Ewan Snedden. I work as a solar PV design engineer, have done for several years now, and do all range of solar PV systems from fields of PV, agricultural buildings to domestic solar, and that's what we're looking at today. So first thing with domestic solar, you can see this picture here. How PV works, really, the panels on your roof, they gather the sunlight and that produces electricity. It produces what's known as DC power, direct current. This isn't the type of electricity that's used in the house, it's more what a battery will produce. So this DC power needs converted into alternating current, which is what's used widely on the energy network and in everyone's houses. So the key components really to the PV system would be the modules going on the roof, collecting the sunlight, and then the inverter, which is basically a DC to AC converter unit, and it will allow the power generated to be used within your house. And then there's various generation meter for recording how much power you produce, and any isolation devices within the system. So you see on the next screen, I've got a little schematic basically showing you how the PV system works. You've got the panels on the roof generating electricity from the sun, this AC to DC inverter, and then the power will go onto the house's distribution board. And so your main power board in your house, if the supply from the PV is sufficient, it will basically power any load that's in your house, and any excess electricity will head out onto the grid. And if the PV isn't producing enough for the house's demand, it will still use everything it can from the PV panels, and it will just get a little bit more in from the grid that it needs to complete the power demand for the house. So basically, as I said, key component will be the modules. Most modules are around 1.6 meters long by about 1 meter wide, and they're between sort of 3 and 5 centimeters thick. 90% of the solar PV modules that you'll see on people's houses are made from silicon, the same as computer chips. Broadly, there are two types of silicon modules you can get. can get what's known as polycrystalline, which tend to be a blue colour, and you get monocrystalline cells, which tend to be a black cell and black module, which can look better on people's roofs. Typically, solar PV panels should last sort of 30 to 50 years. Over time, the power output from the panel will reduce slightly as the sunlight sort of disrupts the structure of the solar PV panels. Typically, solar panels are about 250 watts per panel, but different manufacturing methods means you can squeeze this up slightly higher to sort of 300, 330 watts per panel. And then these panels will be arranged in an array on the house. Okay, the next bit then was the inverter. So it's quite complex electronics within the inverter unit. So they tend to take the DC power and convert it into the AC power that's used in the house. And preferably, these inverter units should be fitted somewhere where you can get access to them. So I usually think in the electricity cupboard in the house, or in the garage perhaps. I prefer not fitting them in lofts because people rarely go into their lofts, so if there are any problems with it, they don't notice them as quickly as they would if it was in their cupboard or in their garage. Typical lifespans for inverters is sort of around 10 years. Usually when you buy a new inverter, you can sort of extend the warranty period. Most come with a standard 5-year warranty, but you can extend it to 10, 15 years depending on how much you're willing to pay for the extension. I wouldn't always extend the warranty beyond 10 years because I think the way that the electronics are developing and the price of these inverters, in 10 years' time, if your inverter fails, there might be something better and more efficient to use in its place, rather than replacing it with a warranted old piece of equipment. So here in this diagram, you can see roughly how all the components will connect together. So you've got the schematic showing the panels on the roof, and then the two electrical cables bringing the power down from the roof. Usually I'd have like an isolator so you can sort of disconnect the roof from the rest of the infrastructure in case you're having any work done in your loft. It might be best just to switch the whole system off and things like that. Then you'll have the inverter unit here, which is obviously taking the DC power and making it useful into your house. And then this will be connected back into the consumer unit within your house via an isolation switch. So again, if you ever have a PV system, you've got electricians coming around, just remind them that it's there and they can switch it off, so they're not going to have any issues with that. And then lastly, there will be a generation meter. As I said earlier, that records how much power the system is being generated at any one time. And this is the meter you use if you're going to submit readings for the feed-in tariff to get your subsidy payments. It all comes from this generation meter that records how much power you're producing. Usually the PV system will connect straight into the distribution board. If there's a spare space, and we just fit another mini circuit breaker, and so as a final disconnection on the PV if required. So not every house is suitable for PV. For example, the confession of mine is that I may work in a PV industry, but I don't actually have any solar panels on my house. It doesn't really face a very good direction, and I've got a big embankment to the south. So it's things like that you need to consider when you're looking at your house and whether it's suitable for PV. So the main considerations really is orientation, which way is the house facing. It doesn't need to be south facing to get an effective PV system. We'll look later, you can see that a system that's got an east facing array and a west facing array can actually be really useful to a householder as well, and we'll explain why. The second consideration I'm going to look at is any shading on the roof. Shade is obviously, it's interrupting the flow of sunlight to the panel. So if there's a solar panel that's being shaded, it won't produce optimally how much it can produce. And lastly, the consideration I've looked at is basically the roof makeup, what's on your roof, and looking at how we deal with all those different types of roof structure. An important consideration I put at the bottom here is what I call demand matching. So obviously, when you're in your house, you've got different equipment on at different times during the day, and a PV system will supply power instantaneously, so it won't store it on its own. So if you have the demand, then the PV will meet the demand if it's big enough, and if not, it will export the power onto the grid. Obviously, a lot of people will have heard of battery technology improving, and it certainly is, and that can allow you to use that PV generated power during the day in the evenings when you're in the house. But it's not always about that with the demand matching. Behavioural changes within your lifestyle can allow you to really make the most of your PV system. For example, having your washing machine on a timer so it comes on in the middle of the day can really help make the most of any PV system that you do fit. So the first thing I'm going to look at is the orientation of a solar PV system. So you can see from this chart here that ideally in this location between sort of 30 and 40 degree pitch of the roof, so that's the angle your roof's at, and 35 degrees is sort of the standard pitch of most roofs in the UK. And if it's facing due south, you can see that gives you 100% of the possible output of your PV system. And obviously that will depend on the size of the system and which part of the country you're in. And you can see as you're going towards sort of southwest, it's not really dropped off that much. And then even facing due west or due east, you're still getting 86% of the possible power output of a south-facing PV system. So that's an important consideration, looking at where your demand is during the day and how a PV system can meet that. Because an array that's facing to the west will do very well in the evening time, particularly during the summer when there's still quite a lot of sun, sort of 7, 8 o'clock at night. And because it's facing that direction towards the sunset, it will give more power than the same size array facing south at that time during the day. So this is a little graph I did showing you basically what a south PV system will do during the day compared to the east and west system. So you can see the orange line on the graph basically showing you the power during the day, and you can see that basically up until 9, 10 o'clock in the morning it's not producing that much power, and then it produces most of its power between sort of 11 AM and sort of 2, 3 o'clock in the afternoon. I don't have a PV system because I'm at work at that time. However, if I had a roof that would fit an east and west PV system, I would use that, because most of my demand is before I go to work and after I get back. And you can see that during those sort of times between sort of 7 AM and 9 AM and sort of the 4 PM onwards, the east-west will actually allow more power to be produced during that time, which will obviously run my dishwasher, washing machines and anything like that I'm running in the evening. If you do choose your house happens to be an east-west face, and you're going to fit a PV system to both of them, it's important just to make sure that the inverter that your installer has specified is capable of basically tracking 2 different arrays at the same time. So most of these are called dual tracker inverters, so that's an important consideration for that system. The next thing I'm going to look at is shading, and I'd say that shading within the PV industry is the most significant design challenge. You can see on this picture here, there's this one panel just next to the dormer that's shaded. Basically how a PV system works is all these panels will be connected together, and all of them will be performing the same as this one shaded panel. So eliminating panels from around dormers, any sort of chimneys that you've got on your roof, and you might get a more efficient system to have slightly fewer panels and keeping it away from the shade. And there are ways around this, and there's modern technology. Rather than having one inverter in the cupboard, you can have like an individual inverter on each panel, and that would basically completely mitigate any shading issues, other than the one panel that has shading on it. However, all these little microinverters will increase the cost slightly of the installation. When you have a solar PV installer coming out, they should be looking at your house and giving you an estimate on the predicted yield that your house will experience. And on this chart, you can see the red areas have been identified as sectors of this is the sun path. So the top one is basically the 21st of June. That's how high the sun will get in the sky. And the lowest path will be the 21st of December. So you can see these sections are shaded, which is producing this shading factor, which will reduce the predicted yield of the PV system. So your PV installer should be outlining basically how much shading your system will experience, and will also should be giving you a predicted yield based on the location, the orientation, and any shading considerations that have been identified on the roof. And as I said, the next important consideration is obviously you're going to have people on your roof fitting solar PV to it. The roof's first job, of course, is to keep your house dry. So a consideration will be to make sure, identify how your installer is planning on removing tiles, replacing them, and making sure that they're going to leave your roof sealed and in good condition. Obviously, if there is an issue underneath your solar panels with the roof structure, you're going to have to take the panels off to be able to fix it. So any maintenance issues within the lifespan of the PV system, you should try and make sure that they're not going to become a problem by perhaps getting any minor repairs done before you fit the PV system, so you're not going to have a more expensive repair later. And as I said in the bottom here, speak to your installer, particularly when they're coming out to quote you, and identify what their plan is for fitting the system to your roof, and how are they planning on sealing it, and things like that. The alternative to what I showed on the previous slide, I'll just go back to it for a second. You can see what this is here in the picture is a roof hook. So this is screwed into the trusses of your roof, and then on the end here you'll mount a rail system that the panels then secure to. So this is in the end the bit here that's actually fixing it onto the substructure of the roof. So it's quite important to make sure that's secure. The alternative is what's known as a fully integrated solar PV panel. At Forster Group here, we do a lot of new build housing, so this is the standard to fit on a new roof. You can fit it to an existing roof. You just need to basically strip the tiles off from the area underneath the panels, and then secure down onto the battens here on the roof. The main advantages to an integrated system, one is sort of the aesthetic appeal of it sort of being part of the roof structure is one, and also if there are any issues with the roof, it's easier. You're not having to fix something that's underneath the PV system. If you're going to have any problems, it will be around the edges of the array, which should be easy to fix, relative to broken tiles underneath a retrofit system where you're having to take the panels off to fix the roof underneath. A small number of recently built houses will have a very modern sort of roof tile. It's very hard to retrofit a PV system to. So in the past, we have actually had to strip the tiles off to put the PV system on. So it's just a consideration when you're there. As I said earlier, ask your installer and make sure you're comfortable with how they're planning on treating your roof. Solar PV installers are required to be MCS certified. Now, the MCS certification is both with installers, and MCS also accredit the panels that are being used to make sure that they're to a suitable standard. And basically, if you want to claim the feed-in tariff support, both the panels and the installer have to be MCS accredited. There's other things the installer might well possess. It could be part of the REC scheme, the Renewable Energy Consumer Code, and this is sort of a guarantee to say that they will treat their customers with respect. There's other ones, obviously, if they're STA members, that can be a sign that they're they care about the industry rather than just caring about taking your money and running. So it's a useful consideration for that. And also there's various electrical certification bodies. You see a lot are the National Inspection Council for Electrical Installation Contracting members. And you can often see this little logo on their vans and things like that. But again, quiz your installer and make sure that they've got all this in place. Find out what type of panels they're planning on fitting. Find out what type of inverters they're planning on fitting, and you can get on the internet and have a little look and see what reviews have been left for all the different kit that they're planning. The installation process for domestic solar PVs fairly straightforward. Tends to take just like 1 day, maybe 2 days if your roof is particularly complex or if there's other electrical work needing done. Solar PV is considered permitted development, so there's no need for a planning application unless your house is listed or in a conservation zone. But even that doesn't stop you being able to fit a PV system. It might just limit where it can be on your house. Often you'll find in listed buildings and conservation zones, they would prefer the PV not to be facing the road. So you'll find that maybe if the street's running east to west, one side of the road won't be able to have a south-facing PV array, but the other side can, which is a little unfortunate. But that's just the planning guidelines. If you're wanting to claim the feed-in tariff, your house needs to already be quite energy efficient. So usually it would be a D rating on an energy performance certificate. And so once if you've accepted a quote from an installer, you might well find that you'll have an energy assessor come out and assess your house before they come and fit the PV to make sure that it's going to meet a band D EPC, so you can claim the highest rate of the feed-in tariff. If your house is not going to achieve a D rating, you can still apply for the feed-in tariff. You just get less pence per unit of electricity that's produced. The first consideration I always have whenever I have anyone coming to work on my roof is looking at safety. I really not keen on people being up a 2-story house on a ladder, as you'd suggest. So again, before they come, quiz them, make sure they're specifying something that you're happy for them to get onto your house with. And obviously if you're comparing 2 quotes and one is more expensive, it might be that the cheaper one are planning on going onto your roof on a ladder, while the more expensive one is going to do something safer with some scaffolding. So maybe ask them about that and see what their plan is to get onto the roof. Usually it's a sort of 2-stage process. Often there'll be sort of 3 guys who come out. 2 of them will work on the roof and fit the panels and the rails and feed all the cabling into the loft space. And then you'll have an electrician who will carry out the rest, and he'll feed the cables down into the house, fit the inverter, and then do all the testing and commissioning stuff that they need to do. As I said, Typically it takes 1 day, but it could be 2 depending on the complexity of the roof and other things. The installer then should really show you how to use the system and show you how to identify if there's any faults, if there's any problems, and also they might try and train you a little bit on how to make the most out of your PV system, whether that be behavioural changes or advising you to perhaps fit a different piece of equipment that might increase the use of the power within the house. Typically, a unit that would do this would be an immersion control device. So if you've got a hot water tank that's got a boost electric immersion on it, what you can do is you can basically connect your PV system to a control unit. So once your PV system starts to export electricity from the house, as in it's already covered the demand in the house and it's still generating more than you're using, it basically just diverts this power into your immersion tank and just slowly heats the water through the day. And it's a very cost-effective way to get quite a lot out of your PV system if you already have a hot water tank in the house. I know someone who has one of these fitted, and they say they don't pay for hot water from basically May until October. And it's entirely heated through the day by their PV system, which allows them to make the most of it at night. The other thing they might try and encourage you to do is looking at a battery storage system. Currently, there's no financial support from the government for them, although there is rumours that that's going to come in the future. They are still quite expensive for what you can get out of it. But the way that the battery technology is developing, the cost of batteries is sure to plummet in future. So you might want to fit a PV system now that's compatible with a battery. So once that price point hits something that you want to go and invest your money in again, your PV system's already ready just to take the battery system in it. Typical installation costs are around £5,000 to £6,000 for a 4 kilowatt system, which is roughly about 16 panels on your roof. Obviously, if you have a higher output panel, you might need not quite so many of them. And the one thing that can really vary that price is the access onto the roof. So if it's quite high and they're having to build a scaffold, that's going to cost a little bit more. In summary then, look at your house's orientation and shading and see if the solar PV is going to be suitable, and decide if your energy demand profile, if you're going to use it as much of the electricity as possible, and that will make it much more effective for your lifestyle. Think of how you want it to look on the roof. I think a black solar panel looks better on a roof than one of these blue silver ones. So I would probably pay slightly extra for the black panels. But the most important thing I'd say with solar PV, get several quotes and take your time and decide about it. Although the feed-in tariff does digress over time, it's not a significant amount. You're much better just to make sure you're getting the sort of system that you think is suitable for your house and that will work for you. £5,000 to £6,000 is a decent investment to make, so take your time and make an informed decision. Also looking at from your installer, see what they're proposing to fit, what brands they are, and then consider the warranty. You might want to extend the inverter warranty for a further 5 years, and it's usually not that expensive to go from 5 to 10, and that's what I would do. And lastly, once the solar is fitted to your house, it can be a good idea to try monitor your energy usage over the next couple of months, monitor how much the PV is producing, and then just try and see if you can find a way to maximize the benefit of the PV on your house, to sort of minimize your bills, so you really get all you can out of the system. And that's basically PV in 20 minutes in a nutshell. Obviously here to answer questions at the end, if there are any. So just fire away, and thank you very much for listening.
Okay, that's great. Thank you very much, Ewan. That was extremely interesting, and I'm sure everybody found it very useful. Without further ado, we'll pass over now to Mark Bragg, who's going to tell you about his own personal experience of solar PV. So over to Mark. Okay, sorry about that. We're having a technical issue, which is unusual. I think what we'll do is, whilst Mark's trying to get himself ready, what we'll do is we'll cover a few questions that have cropped up. So I'll take the first question. So it's Anthony here at Energy Saving Trust. We've had a question come in about whether we can recommend installers or certain brands or products. At the Energy Saving Trust, we give sort of independent, impartial advice, so we can't necessarily recommend specific installers or products. But what we do recommend you do is to use someone who's meeting the standards under the microgeneration certification scheme. So that's the MCS standards. So we recommend you use an MCS installer and an MCS product. And then you have certain reassurance that that installer and product is meeting certain requirements. And there's also a consumer code and consumer protections associated with that. So you'll have those additional protections in place. The next few questions were more technical questions that I think it may be useful for Ewan to take. So Ewan, I'll just pass a couple of questions over to you. The first one is a question about whether you can link, or what the considerations for linking a PV system to a home battery.
I can answer that. So your consideration really for whether you link it to your home battery is, first thing would be, as I was saying earlier, your demand profile. So if you need your electricity in the evening and night time, then yes, fitting the PV system to a battery is going to be the best solution for that. However, perhaps if you're in the home during the day, it can be cheaper and more effective to move some of the demand that you usually have at night into that period where the PV power is available. So that would be, running your dishwasher and stuff during the day rather than in the evening after you've finished your evening meal. So it's a combination of looking at all of those things together. Does that cover it, do you think?
Yeah, thank you, Ewan. Next question was about someone asking about the efficiency of polycrystalline versus monocrystalline panels, and also the sort of how to maximize the efficiency of the entire system, which will of course take into account your inverter as well.
Yeah. So the efficiency of the polycrystalline cells is generally slightly less, but what you'll find is that the way that a monocrystalline cell is made, the polycrystalline are ever so slightly larger, and they cover slightly more area of the module. So what you'll tend to find is, for example, a 250 watt polycrystalline solar panel will have exactly the same efficiency as a 250 watt monocrystalline panel. The main difference you'll have is perhaps your roof space is only sufficient to fit 14 panels. So if you use a higher power monocrystalline panel, for example, a 275 watt module, you'll get more power out of the same roof area as you would with the lower efficiency polycrystalline panels. I also think that one of the advantages of the monocrystalline panels is I think they're likely to last longer at a decent power output than the polycrystalline. And now I'm talking sort of 30, 35 years time. The monocrystallines might well have stood up to the test of time a little better.
What we'll do is we'll change the presentation over to you, Mark.
It's a 1.5 kilowatt system of 6 panels, which feeds back into a 1.2 kilowatt inverter. Just a tiny wee small system that has some degree of use on the network. So late in 2001, there was a LG 1.5 kilowatt screen panel used, and then later on in 2015, there was an 8.5 kilowatt 26 panel system. Part of that you may be able to see is 7 vertical panels there. And you can have, of course, more than 4 kilowatts on your domestic property. There's a sort of a rumor going around that 4 kilowatts is the limit, but it's not the case at all. You can have more if you wish. The angles in my systems are not ideal. Some are horizontal, some are 45, and some are perfect at 30 to 40 degrees. But I did get them installed to meet the deadline. One of the lessons I learned is I would look very carefully at the feed-in tariff limits, and I made a slight mistake of getting 10.08 kilowatts, and that put me onto a ever so slightly lower rate. So I would be careful and just go under 10 kilowatts if you want to. Moving on, this is the bigger of the two systems with a couple of ABB inverters, the 3.9, 4.6, and they're installed out in the rain, but in the outside, and they are in a wood shed where I basically the air can wrap around through the coolers just underneath the ABB signs. You can see the cooling fins, the aluminium cooling fins, and my hand is up there on the export meter for the 8.5 kilowatt system, and that is below there is the wood shed, and as you can see there's 45 horizontal and vertical panels, and yeah, it has 3 purposes: contain the panels and the inverter, keep the air cool around the inverters, and circulating in the wood. You might notice there's some gaps between the panels, so it's not a solid wall, and that helps me to dry out the wood. I'll speak more about the wood later on, and I saw up the wood there using an electric saw, because I actually produce far too much electricity in my house. Now I have a device called a solar iBoost, which diverts the excess power into a rather oversized hot water tank. It's a 300-litre hot water tank, which has 2 coils on it, one for the gas central heating boiler and the other for a future either would link up to a wood burning stove or solar thermal panel. So this does the same as the Immersun. I had an Immersun originally, but it just didn't seem to work, and we couldn't really work out why. So I just got it uninstalled and put in this, and I haven't had any problems since. So I found that more reliable than the Immersun in my particular house. The device on the left is a sensing device that works off the main switchboard, sensing when you're actually exporting. Yeah, so it's the oldest house, one of the oldest houses in the village, trying to make it more energy efficient. It's an old house with new tricks. It's got a super efficient gas condensing boiler, which is in the milk parlour, and the tractor shed where potatoes were stored. Part of that has the lean-to, which is what holds the panels. Today it, however, doesn't produce food. It produces electricity and a little bit of heat. Just to the right there, there's a tiny little solar panel. This is just for a little LED light, and I've got 4 or so of those. And you think, oh well, why don't I just put them throughout the whole house and have more of them? Well, they probably aren't economical, really, compared to mains power, but they are just a bit of fun, and you don't necessarily have to buy these things to make sure they make money. You can just do them for fun if you want, but they are useful, particularly if there's a power cut or something like that, or you lose electricity supply to the garage or the wood store. You know you've got a backup anyway. So this is part of the original system, which is 1.5 kilowatts. On the right is the 6 panels at a near perfect angle of 45 degrees. The 1200 watt Sunny Boy inverter mounted inside the house. It does make a little bit of a buzzing sound occasionally when it's at low voltage. It just takes a little time to sort of warm up and get going. But once it gets over 150, 200 watts, you really can't hear it for the rest of the day. It produces a small amount of heat in the summer, which is not really when you want it. But yeah, it's there in a cupboard, and it is worth bearing in mind that the inverters do tend to work better in the outside where they're kept colder. After about a week of installation, it stopped, and I couldn't work out why, and I looked around it, and I was thinking, what's going on there? But as you can see, I did find the culprit in the end, and it was one of my cats who got her claws onto a cable and pulled it out through a switch. Nothing dangerous, but that lost me 3 days of production, and she's well named for a cat, Trubs, so he's always getting into trouble. Anyway, moving on, it is it's not a perfect installation. There are dormer windows either side, but there are ways of improving the efficiency of it, and I have plans to paint a little bit of white on the roofing and things to reflect a little bit more photons onto the cells, and perhaps improve the efficiency by another 5% or something like that. The key thing was that I made a decision to install the first system, and it worked, and I have no regrets. It's worked perfectly since then, and it's been a good investment. Yeah. What do I do with all the electricity? Well, I now use it, and it's changing my lifestyle a little bit. Quite a lot actually. I produce too much electricity, so so I have this electric car, and that's effectively my battery supply. And things like using the copper kettle on the gas stove is no longer a thing. I use an electric kettle, and all the other petrol devices are on eBay now, and I'm replacing them with electric. So here's the charger, and there's the car gets me about 15 miles or so, and that's fine before the electricity takes over. Here's how I heat the house. I heat the house through a gas boiler, but I've got a couple of wood-burning stoves as well, and of course I chop up all the wood using my electricity, and nothing goes to waste, and I even produce my own fire lighters and things. We've got a Rico heat there on the left, which is a blue hot air pump, like a cold air pump, which gets cycled through the stainless steel tube, which goes through basically up into the chimney, and that blasts some very hot air into the room quite efficiently. And I've got a couple of stove fans, which are gadgets. I admit I like using the gadgets, and that's all good fun. So that's about it really. I hope you enjoyed that. Have you got any questions?
Okay, brilliant. Thank you very much, Mark. And thank you, everybody, for bearing with us whilst we had a couple of technical issues. Hopefully you found both of those presentations useful. Thank you to both you and Mark for their time today. As I mentioned before, we've been recording the webinar, so we'll be circulating it afterwards. I just wanted to cover a couple of final things as we have run slightly over and don't have time for any more questions. So further support for installing solar PV. There's some funding schemes that you may or may not be aware of. The first one is the Scottish Government funded scheme called the Home Energy Scotland Renewables Loan Scheme. That's an interest-free loan, Scottish Government, and you can get up to £2,500 for a solar PV system. You can get up to £10,000 for a renewable heating system. That's only available in Scotland. And then across the whole of Great Britain, there's something called the feed-in tariff or fixed scheme. and that basically pays you for the amount of electricity your system generates, and also for the electricity that is exported back to the grid. That basically rewards you for the renewable energy you generate, whereas the loan scheme helps you pay for the system up front. There may be other schemes available, and your local Home Energy Scotland Advice Centre will be able to advise you about that as well. Within those centres, the Home Energy Scotland Advice Centres, again funded by Scottish Government, you can get free, independent, impartial advice about renewables, and then specialist renewables advisors there too. You can speak to in much greater detail about your property and the best way of improving it. A couple of other things that you could do. There's something called the Green Homes Network that we manage through the Energy Saving Trust. That lists lots of case studies of people who've done things to their home to improve them. Mark Bragg is a public somebody who's on the network, and you can go and have a read about what people have done, and we can also put you in touch with them if you're interested in speaking to them on the phone, or potentially even going and visiting them in their own home to see what they've done. We talked about MCS certified installers earlier. The MCS website has links to all of these tools, but there's also a tool that we run in Scotland where installers can put lots more information about themselves than they're able to on the MCS website. And there's also review ratings from their customers. So there's a link that you can see on the screen there to the Renewables Installer Finder. And then there are some other websites we've listed here, Solar Trade Association, MCS, Renewable Energy Association, and many others where you can do your research. But what we find most people do to start looking into what they're doing, or to find out more, if you've already started by speaking to Home Energy Scotland, it's a free phone number, 0808 848 2282, where you can get personalised, localised support and advice. So finally, I'd just like to say thank you again to everyone for attending today. We've got some future webinars here. We've got one about domestic heating incentive in a couple of weeks, and then there's going to be one about more details about the feed-in tariff scheme and other renewables later, probably in March, and also one about energy storage, including batteries. Again, that one will be in March. So you can keep up to date with what we're doing through a link on the website there. And I hope you found the session useful. Thank you very much again. Bye-bye.